last one is derivative. Okay, I will try to make a summarization again that what is the difference between PI and D? P is something that you try to change the output by changing the gain. And again, in this case, is called KP in our industry. Then the next thing, we also have a possibility to change the rate of change at the output by tuning this KI parameter. And this is called integral actions. The last one is derivative. Derivative, we'll think about that. We also have another possibility that's to make the delta V at the input. We try to define what is the difference of the error from one point to another point in the next time intervals and tuning with the parameter KD. So you will get exactly one number that is depend on the rate of change at the error. The rate of change of the error at the input. And so we can make very fast reactions when your input has the change like in the step change. If the rate of change at the input will like the step change like this, for example, you have a chain of error like this, it is called step change. And that means if the time interval from this second to the next second, you have a lot of change, then you will have a V out that is printing very large values. So in this case, if you have a derivative circuit and you give the error like a step change, or I will call this with this symbol, a step change input. Then you will expect to have the output something look like it comes. But if you use the op-amp to be the derivative circuit and you put this input error at the inverting pin, you will expect to have something in the negative side, like this. That is mean your output will change a lot when the error change with the large values. But you have a very small change at the error, then you will have a smaller response at the output. So derivative you use in the system that you have an initial. Derivative we use so stable for initial in time. What is initial in time? Function. How can we explain the system that has initial? Let's make an example of a motor. Motors. suddenly when you supply the voltage, you will see that motor will consume a lot of current, very large current at the beginning, and then the current will go to the nominal state. And this is called the inertia system. มอเตอร์เป็นตัวอย่างระบบที่มีความเฉื่อยก็คือต้องใช้กระแสอัดเยอะๆเราจ่ายไฟปุ๊บมันจะกินไฟปึ๊บแล้วหลังจากนั้นมันก็จะรีบลดลงมาที่นอร์มัลกระแสนอร์มัลระบบอย่างนี้ต้องการอัดแรงๆเอาเริ่มต้นระบบที่มี inertia. The next example could be something like heater. Heater, if you want to increase the temperatures, you must first put a lot of power to the heater. That is the control system that you must use. ระบบที่ต้องการอัดช่วงแรกๆเยอะๆถึงจะใช้ดีดังนั้นในอุตสาหกรรมส่วนใหญ่ก็จะใช้แค่ PID เฉพาะระบบที่คอนโทรลฮีทคอนโทรลอะไรที่เปลี่ยนแปลงช้าๆก็ใช้ PI อันนี้ usually we have 5 mode for PID control. As I told you from the beginning, that we can use only P alone, I alone. We can use PI, we can use PD, and at the end we use PID. Due to the property of each parameter, then most of the time I see the automation system in the industry use PI and PID. But in Thailand, I have seen that always use this PI. For example, for level control, for heat, for heat usually must be PID. Heat control, temperature control. We have to use PID to control the actions of motors. Like in robot industry, you must use PID. Otherwise, you cannot change the position of the motor in time. Levels or the ratios, the misters, or ratio control. Sometimes we also can use the level with PID as well. Also, it depends on how you can understand PID. More or less, you can control as well. จริงๆแล้วบอกว่าทุกระบบใช้ PID ได้นะแต่ไม่เสียก็ถ้าจำเป็นก็ค่อยๆ PI ถ้าไม่จำเป็นต้องเร็วมากต้องใส่ So derivative จะประมวลผลที่เรื่อง input อัตราการเรื่อง input ซึ่งมันจะทำให้เอาผลเปลี่ยนเยอะมากโอเคเราใช้ derivative ใน process ที่มีความเฉื่อย energy resistance next thing, then we have to find out what should be the circuit that I can use as an analog derivative controller. And fortunately that we have a differentiator. Next step, we will talk about the system, the circuit that can be used as a derivative controller. That is called differentiator. The differentiator is must be written like this, but it's pretty easy because you simply just change the position of the capacitor and the resistor in the feedback loop. That is capacitor. Then you have a resistor. So you can recall last time the integrator. The integrator, you will have an exchange position between capacitor and resistor. This called CD, and we call this RD. Input of the controller must be VRL, as you know from the differential amplifier. And here is the Vout of controller. Make a close look, and then at this point, virtual ground, you will have IF and you will have IE. And output here has no current consumptions, then you have 0 0 amp. Okay, let's continue. We will start to solve the equations from this point. The point as the Kirchhoff law that we have the IF plus IN can equal to 0 and 0 amp. That you have IN plus IF is equal to 0. So if I change IF to another side of the equations, I will get IN equal to minus IF. IN, you have learned from last time that IN is the current that the capacitor will keep inside itself and then try to evacuate when there is a load. Then you know that IN is I from the capacitance value. You can note the capacitance CD multiplied with V across the capacitance CD if V CD by dt. So the same equation like last time. And output is the voltage across RD. Voltage across RD is V out minus 0 here. Then I will write only V out is V across RD over RD. Then try to rearrange the equations. At the end, I will get V out of controller is equal to minus. I change the position here. Simply just put CD to another side of the equations, or no, put RD to another side of the equation. Then I will get RD multiplied with CD multiplied with dV. VCD is nothing else than V across the CD, and V across CD is Euler minus 0. Then you will have V Euler over dV, and that is all from the equation of the differentiator. Let's take a close look at the equations again. Here, RD times CD is the factor that is called KD. So KD is equal to RD multiplied with CD. KD is also when R multiplied with C, or we call them constant, we can call them constant of differentiators, or there is a constant of differentiator. Something is look like that is pretty much easy, but it's not easy like what you see. If my computer has a problem, maybe I have to use the computer from the first table.
มันเดี๋ยวมันมีเวลาแต่ไทยดีนะนี่ตามเราเข้าใจเขาไม่ไหวมันไม่ดี
วันนี้เราไม่เขียนวันนี้ปัดไทยดีกว่า
ก็คุณจะให้มันไม่มี
ก็มันไม่มีเห็นว่ามันไม่มีตั้งแต่
ก็มันก็มีเดี๋ยวเขาบอกที่ว่าจะเขียนผิดเนี่ยเป็นไทยเนี่ยเพราะว่าไทยก็อาจจะเป็นไทยแต่ได้คำว่าไทยนี่คือต้องมีจอจักรที่ได้แค่ทำค่ะลิงก์ก็ได้ถึงอะไรก็